Okay, the final one is x equals, this means the exponent is a positive rational number. How about negative rational number? Again, we have minus m over n x raised to the minus n over n minus 1. The rule are all the same. Put the exponent as coefficient and decrease the exponent by 1, then this is the differentiation rule. Differentiation formula for power function. Okay, again, because we will use this one and this one we used this formula, so we have made this assumption. Again, m and n are relatively prime, and m and n are positive integers. If x is not 0, then this number is also non-zero, which is the reciprocal of this one. Then we use the quotient rule of differentiation formula. In differentiation formula, we square the denominator, differentiate this times this minus 1 times differentiate this we obtain by the previous one. So this is 0 minus here. And we have the coefficient m over n. About the exponent x, we have m over n minus 1 minus 2 times m over n. So how many? Minus m over n minus 1. Bingo. So all the same. How about when x equals 0? X equals 0. We have to discuss separately. Okay. Of course, here we assume M and N are relatively prime. For this function at 0, we consider if n is odd and m over n is positive. Okay, because n is an odd number, so this function defined for every real number. So 0 is defined. At 0 plus h is also defined, no matter h is positive or negative. Use law of exponents. Because this number is greater than 1, so this is positive. A positive number. So this limit is 0. Okay. This is a positive number. If this number is less than 1, then we consider again the limit of this difference quotient, but we don't know whether n is odd or even. But when h is positive, this value always defined. Okay, because this is a positive rational number, and the numerator is a constant, non-zero constant 1. When h approaches 0 from the right, this limit does not exist. In fact, it is an infinite limit. Okay. So, no wonder. F prime 0 does not exist. Finally, if n is even, this function is undefined. For negative real number x, okay, because h approaches 0 from the left, this is a negative number. This function, because n is an even number, this function is undefined for negative real number x. Okay. So the first term is undefined. Undefined. Undefined does not exist, so the length cannot be a real number, a finite number. Okay. So I'll give some examples. For example, if this one is greater than 1, okay, greater than 1, so here there's a horizontal tangent. If less than 1, odd number, we have a vertical tangent here, infinity. Less than 1, and n is an odd number, infinity. When n is an even number, when n is, this is greater than 1, because undefined, so it does not exist. Less than 1, less than 1, infinity. So anyway, if m and n are positive, we have this case, this case, this case. Only if the exponent is greater than 1, here it will be smooth. Which of them ones most, but this an even number. By definition, this is the, sorry, fourth root and fifth power. Only to find for non-negative number. Same. Okay. When this is a negative one, if this is a negative number, negative, when this is negative, this function is undefined at 0. Okay. Undefined at 0. If f is negative, f0 is undefined.